Hey guys, so we saw the experiment, the projectile motion experiment in the previous video. So let's go through some sample data. So there is some sample data for the experiment. So this is the angle. These are the three value of ranges which I mentioned in the video. So the first thing is, so now we want a plot of r average versus sine 2 theta, right? So let's make a column. We'll go through all the details on how to make the graph and how to find the slope and how to find v naught from the slope. So let's make a column for sine 2 theta. Okay, so 2, and then if you want to put in the symbol is over in the basic, no, in the Greek letters in these symbols. Okay, but I already have it over here. So okay, now if you want to put in, so I want the sine. Excel has it, but Excel calculates it in radians. So what I'll do is I want 2 first, so 2 multiplied by theta, and then I'll convert that into radians, right? So 180 degree is pi radians, okay, which means that 1 degree is pi divided by 80. So let's say pi is typed like this, and then divided by 180. So that will give you sine 2 theta. You can just drag it down. As you know, in Excel, you can just drag down to get all the values for the corresponding cells. Okay, now we have sine 2 theta. Let's get our average. So our average, sorry, these values are in meters. I had these in centimeters before. Change the values, I forgot units. Okay, now we'll get our average on meters also. Okay, so let's write the units over here. So equal, use the average function, select the cells, and then close the bracket. There you go. So you get your average value here. Then you can just drag it down. So you get all the average values for your data. Right? You can also calculate the uncertainty in, remember the U of our AV column. So it's also going to be in meters. So what you can do now is, so the way we get the standard error is by using the standard deviation. So that's STDV of sample, and then you can select the three values and then divide them by square root of 3, because you have 3 values in your data. Okay, so you can just drag that down to get the whole thing. Okay, now we want to plot our average versus sine 2 theta. So let's select sine 2 theta column. So uh, so in my version of Excel, this works with the left control. So you press the left control and then select this column, and then select this column, go to insert, and then scatter. Oops, no, not this one. Wait, let's do that again. So there you go. There you go. There you go. And then there you go. Okay. So so again, you press Control, select the two columns, go to Insert, and then select Scatter Plot. Okay. Now you can add the title if you want, RAV versus sine 2 and then theta. Okay. I'm not doing that, but you can also take this guy to the subscript. Like you can go home to home and font, and then you can press subscript. That takes it to the subscript. But it's up to you if you want to do it. And you can add titles. So you can press. You can click on this these numbers on the y-axis. Go to Design, and then axis titles, so primary horizontal, so you can see that we got that, and then you can go and then press click on primary vertical. There you go. So so this is our average range, which is in meters, and then this is our sine to theta. Okay, so we have the titles now, and sine to theta has no units, obviously. Now you can add the trend line. You can right click on the data points, add trend line, and you can select display equation, display r squared value. Okay, so you can only display the equation. Just don't confuse this r squared with this r. This r squared is the statistical measure of how good your fit is with your data. So if it's close to 1, your fit is really good. So you can see the slope over here. And as we discussed in the video, that the initial velocity is obtained from the slope. So we can now, let's do the line list. Okay, so let's do the line list, and you can again select y data. So this is your y data. Just be careful with this. Okay, this is your y data, and then your x data, and then true, and then not true, no, false, it's true. Okay, so then you go close the bracket, select the cells. We've done this in another video. Control Shift Enter, Control Shift Enter, and then you get the value. So this is the slope, this is the y-intercept. So you can yeah, this is the error in the slope and an error in the y-intercept. So the value of v naught, right, which is the initial velocity, is equal to square root of the slope, okay, multiplied by 9.8. 9.8. Okay, so that's 2.5, which is a reasonable value. The actual value is around 2.6, so this is good enough. And yeah, I guess that was it for the yeah. Oh yeah, one last thing, the error bars. Yeah, the error bars you can add by clicking on the plot. So you get when you click on the plot, you get these two options. You go to design, add chart elements, you go to standard error bars. So you get the error bars also, and um, if you just want the vertical error bars, you can click on the horizontal error bars and press delete, so that get rid of the horizontal bars, so you just can see the error in the range. Okay, this is the standard error bars for the range. Okay, so let me take a look at my standard sheet and see if I got everything. Yeah, I guess that was all for today's video. If you have any questions, post them in the comments. So this is analysis you should, you just one last thing is, these are the steps that you should remember. We go through almost the same steps in every experiment. So make sure you take a look at this video whenever you need it for other experiments also. So thank you for watching, and please subscribe. Bye.